Hello, my name is Warren Young, aka Tangent of TangentSoft.net. This is Tangent Tutorial 4, How to Desolder Electronic Parts. In this tutorial, we're going to be discussing the tools and techniques you need to be able to get electronic parts off of circuit boards after they're already soldered down. If you only get one desoldering tool, get this. This is called desoldering braid, and what it does, you saw me use it in the previous tutorial to soak up some excess solder. You put it on top of the joint where the excess solder is, and then you heat the joint through the braid, and that draws the solder up into the braid using a wicking action. And so you can also see it called a desolder wick. This is the standard 0.1 inch variety. There are thinner types, but they don't soak up as much solder, and so I don't like to use them. So again, if you only get one desoldering aid, get this stuff. This is great. The next most common desoldering aid is this. This is a desoldering pump. And the way this works is you push down this plunger, that cocks the mechanism, and then as soon as you press this button here, you get a vacuum here at the tip, and that will soak up, or suck up any solder into the chamber here. And so just pump, and there it goes. And so what you're doing is with one hand you're heating up the joint, and with the other you've got this over the joint real close, and then you just press the button and it sucks the solder up into there. I don't like to use it for removing solder from around a component leg when it's already down on the board. I find it more useful for cleaning out holes after I've already removed the leg. So usually I'm more for the desoldering braid for getting the part off the board to begin with, and then I use this to clean up some of the harder messes. Alright, now this is a little less common. This is liquid flux. Most often you'll find liquid flux in a pen form where you just kind of tap the pen down onto the joint and it will let a little bit of flux flow. I find those kind of messy, and so what I've been doing is I've been buying flux in larger bottles and then putting them into these smaller squeeze bottles. I wish you could buy these individually, but you really can't. But in terms of desoldering, I mean, you may have heard of liquid flux used for soldering, but it's actually a great desoldering aid because during the formation of the joint, you're going to burn off most of the flux, and then you're probably going to clean the rest of it off after you form the joint, and then you're trying to remove solder that doesn't want to flow, right? And so what you can do is you can put a little bit of flux on the joint, and that will help the solder to flow out into, you know, the pump or whatever it is, and that will help you to get the part off the board. The only reason not to use this really is if you're using good quality desoldering braid, and this stuff should have some flux in it already. And so it's usually not necessary to add a little bit of flux when you're using this. In fact, after you remove some solder from a board with this, you should see a slight kind of sticky, shiny residue left behind, and that's a little bit of flux that it puts onto the joint. But if you're trying to clear something out, especially with a desoldering pump, and you're trying to clear solder out of a hole and it just doesn't want to move, add a little bit of flux to the joint, and I'll bet you find that it flows out quite nicely. The final class of tools we're going to cover just kind of briefly because they're specialized and expensive, and a lot of people just aren't going to use them for those reasons. But there are a whole bunch of what I call hot tools, and here's just one example. These are called hot tweezers, and you can see the wide blades on the ends of these. These are for SO8 type chips. You can get all kinds of different ends for these sorts of things. Other common tools are desoldering irons, and so they're a combination of a soldering iron and a desoldering pump, and so they have a squeeze bulb on them, or perhaps an active pumping mechanism, and so you heat up the joint and then you make it pull with the same tool, and so it saves you from having to use two tools, and it's more effective than either separately. But it's a separate tool, and I don't like to have a whole bunch of separate hot tools on my bench, and so this is as far as I'm willing to go, is just one set of tweezers. Another common one is called a hot air rework station, and what it is basically is it's kind of like a really focused heat gun, and so it's used to put hot air onto a component, and it's hot enough to melt the solder, and because you're using the air, you can get it over a wide area. And so it's really useful for large surface mount parts. So you have a whole bunch of leads and you need to heat them all up at once. A hot air rework station can be useful for that. The best way to remove a given part depends on the number and arrangement of the part's pins and on what tools you have available. I have here a populated pint board, and the first technique we're going to start out with doesn't use any of the tools we saw before. It's just a simple way to remove any 2-lead surface mount part. I'm actually going to go for one of these larger ones on the back side just because it's easier to see. So we're going to remove this diode. I call it the oscillation method. All you do is you take your iron and you heat up one joint side, then the other, and you're just going back and forth, spending not much time on either, and eventually it just slides right off the board. You don't put very much pressure on it. You're just kind of heating up the joints and you do it fast enough so that when you're heating up one joint, the other one is still molten, and eventually it just slides right off the board. You can use that for resistors, capacitors, diodes, any 2-lead part that you can get at the pins really easily. Then once you're done, and you're presumably going to put something else on here, you can use desoldering braid. I'm just heating the joint through the braid, and that's going to suck up all the excess solder that I left behind from my. You can see the little shiny spots here in the braid. That's the solder that I pulled up from these pads after I got the diode off. So that's the oscillation method. The second technique we're going to cover is what I call the solder blob method. And what I'm doing is I am going to put a whole bunch of solder along the edges of these SO8 pads. And what I'm doing is I want to intentionally bridge all 4 pads on a side. Okay. And so you can maybe see that I've got all of the pads on each side completely covered with solder. And at this point, we return to the oscillation method. And so it's heat one side, then the other side. Again, not putting much pressure on the part. We're not trying to force it off, we're trying to heat it off, and eventually it just slides right off. Okay? And so you can use this with any part that has a whole bunch of pins on 2 sides. If you've got a 4-sided part, like a QFP package part or anything like that, this is not going to work. It's just too hard to do it with 4-sided parts, but it's useful for this sort of thing. Okay, the third technique is useful for things like electrolytic caps, and this one I call the prying method. What I'm doing here is with my left finger, this finger right here, I'm putting a little bit of pressure on the top of this cap, and then I'm going to heat the joint, and I'm just going to pry it down a little bit. You don't have to get the one pin out the first try. I think I might have managed it in this case, but it's more useful just to get a little bit of movement. And then you go to the other side, and you get a little bit more movement. Come on. There we go. Yep, in fact, I didn't get it all the way out on the other side, and that's normal. So a couple of tries back and forth, and you just kind of pry it up. This is going to bend the part leads a little bit. I don't know if you can really see that, but they kind of tend to spray out now a little bit. But this shouldn't damage the part. This should be good to go for another round if you need to replace it later. So again, not too much force. You're more interested in heating the part off the board rather than prying it off the board. The prying is just to get it to move, not so much as main force. Now that was a through-hole part, and once you've got it off the board, you probably need to remove the solder from the hole so that you can put something else in its place. And so what I'm doing is I'm aligning the nib of this desolder pump with one of these holes, and I'm going to heat up the solder in that hole, and as soon as I feel it start to move, I trigger the pump. And in that case, I didn't get it to come out, so we're going to try this again. So heating it up and pressing it in from the other side, and that time we got it clear. And so I don't know if you can really see that, but that hole is now clear. And so you might have to try that a couple of times, and again, maybe add some liquid flux in order to get that to the hole to completely clear. And then once you've done a whole bunch of joints like that, you can take these pumps apart. You just kind of rotate that around, and you can get the solder to come out of here, and then you can go and use this again and clear the solder off of out of your way. If you let too much solder accumulate in the pump, you're going to find that you'll start to get some spray back onto the board every time you trigger the pump, and so you don't want to make the problem worse. Alright, everything we've seen so far is either a 2-lead part or a special case of a multiple lead part, like the SO8 op amp, which we reduced to the oscillation method. But what happens when you have 3 or more leads with something like this is a TO92 part, is getting this off with either the prying method or desolder braid. None of those methods are going to work very well. So what you end up doing usually, you can try for more complicated methods, but usually, unless the part is really expensive, I take some fine pliers and I just cut the part off the board like so. And now you have 3 single hole desoldering problems, much simpler. And so I'll use the iron to poke these leads back through the hole, and then I'll use some pliers again on the other side to pull the leads out, and then a desoldering pump to clear the holes. A better example of that is actually a dip type chip. Anything that has a whole bunch of leads on one side, unless this chip is precious to you and it's either irreplaceable or just too expensive to lose, I just cut the leads one at a time using some fine pitch cutters, and now we have 8 separate desoldering problems. And so I call this the divide and conquer method. Unless that chip is precious to you, I don't bother with anything else. The only thing you might do to be clever about this is, once you go to replace whatever part it is you just cut off the board, add a socket if you can, and then you'll never have to do that again for that part. Alright, now finally I'm going to show you these hot tweezers, and this is just kind of as a demonstration of why you might want to invest in some higher end tools, and that's because they are very easy when you have these more difficult parts. And I just pulled that right off the board, no trickery. This is going to cause less board damage, it leaves less cleanup work on the chip itself. The chip itself is probably going to be reusable, so it's just a really nice way to go if you have a reason to do it. And I have these hot tweezers because I do a lot of replacement of these SO8 chips, either op amps or various other kinds of chips. If you can justify it, it's really nice to have some of these more specialized tools. Okay, that's all. In the next tutorial, we're going to discuss how to clean circuit boards. So now that you've gone and made a mess of your circuit board, we're going to discuss how to clean it up a little bit. Thanks for your attention, and goodbye.